What is the observable universe exactly? The observable universe represents a part of the universe that we are able to detect and investigate through various telescopes and scientific tools. Nonetheless, this ability is mostly limited because light, our primary mode of information about the universe, travels at a limited speed. As a result, we only have access to celestial bodies and events that occur within a particular range. Phenomena or objects from the distant past cannot be observed directly by us. It is anticipated that the width of the observable universe is roughly 93 billion light-years, a distance significantly greater than the presumed age of the universe, which is estimated at 13.8 billion years at the moment. This apparent inconsistency appears from the continuous expansion of the universe that has previously caused objects to move closer and further away, extending the amount of time needed for their light to reach our perspective. In short, the observable universe is immense and fascinating, but there remains an enormous amount that we have yet to find, thanks to state-of-the-art advancements, such as NASA's James Webb Space Telescope and other research instruments. We are gradually expanding our comprehension of the universe, including its composition, layout, origins, and the numerous events it includes. Come with us as we investigate the discovered cosmic structures identified by the James Webb Space Telescope in the farthest reaches of the observable universe. If you're keen to stay updated with advancements and discoveries in space science, please subscribe to our channel. Make sure you like this video and set notifications to go off. What then exists beyond the observable universe? To cross the line that separates the visible cosmos, we would have to develop propulsion technologies that transcend conventional restrictions on space, such as hypothetical distortions of space and time, like warp drives or traversable wormholes. These ideas from the future have been the subject of much discussion among physicists, with some arguing that these advancements are fundamentally impossible or in opposition to the current comprehension of the speed of light constraint. The practicality of exceeding the speed of light or building extremely advanced technologies is still a topic of intense debate, even though such possibilities are theoretically conceivable. They demand groundbreaking progress in science and engineering, well above our current capabilities of advancement. The premise of the theory of cosmic inflation suggests that the actual size of the universe is at least 103 times larger than what we can see right now. This figure is so staggeringly vast that it exceeds human cognitive capabilities. Since we are unable to perceive or measure anything beyond our scope, we are unable to say with certainty what lies in those unobservable regions. Nevertheless, we can formulate hypotheses based on the information gathered from the most distant galaxies we've been able to investigate. NASA has demonstrated this here indispensably through collaborations with international space organizations and educational establishments. NASA has made significant contributions to the advancement of our comprehension of the universe, even before the James Webb Space Telescope became fully operational. NASA collaborated on deep space visuals taken by the Hubble Space Telescope's ultra-deep field observations. When the Webb became operational, it was assigned immediately to investigate the closest known galaxy. These preliminary discoveries revealed numerous galaxies that shine in the distant universe, many appearing just a few hundred million years after the Big Bang, approximately 13.8 billion years ago. As the universe keeps expanding, light's wavelengths stretch longer across the electromagnetic spectrum, a phenomenon referred to as redshift. The James Webb Telescope is able to detect infrared signals and, as a result, reveal galaxies that were formed during the universe's infancy. By observing numerous faraway galaxy groups, the Webb has provided scientists with important insights for evaluating stellar rates of formation throughout the universe's early phases. The results suggest that a sizable number of galaxies were vigorously generating stars during those periods. Both of these revelations are remarkable and insightful, stimulating human curiosity. Humans have long speculated concerning the possibility of not being the only species of intelligent life in the universe. The most recent observations within The limits of what can be seen suggest that there are many galaxies in the universe beyond our ability to detect. This concept is truly mind-blowing and deeply fascinating given the vastness of the universe. Could intelligent life forms exist elsewhere in the cosmos? The likelihood of extraterrestrials is becoming more believable, causing us to consider the possibility of additional advanced cultures, thousands of planets outside our own that orbit stars exoplanets in the solar system have been identified using methods like the transit method and radial velocity analysis. One or two of these planets might possess Earth-like qualities and potentially promote life. This concept gained additional support from a notable discovery by the James Webb Space Telescope concerning the exoplanet WASP-96b. This celestial body, located beyond our solar vicinity, exhibited an element that surprised with its light pattern: water vapor traces. In addition, the data revealed signs of atmospheric haze and cloud layers. Once present conditions are believed to be unlikely on worlds that might contain life. As a more life-friendly environment exists on alien planets and exoplanet research continues, it becomes more and more difficult to deny the existence of life beyond Earth, while unquestionable evidence is lacking. The expanding collection of evidence makes the concept of alien existence both believable and exhilarating. What about the multiverse theory especially, considering the scale of the universe that can be seen? Let's explore the multiverse concept, also referred to as the many worlds theoretical interpretation framework in both science and philosophy, implying that there are multiple, possibly infinite, parallel universes or dimensions in addition to our own. This theory mainly stems from quantum physics, the study of how extremely tiny particles, like atoms and their elements, work. In specific interpretations of quantum mechanics, simply looking at a quantum system results in it arriving at a single conclusion. However, the many worlds interpretation argues that each observation leads to the branching of the universe, with every possible result occurring in its own separate reality. It's crucial to understand that the majority of multiverse theory is still speculative and, at the moment, lacks definitive experimental confirmation. Consequently, it is classified as a formal scientific theory still being debated. Some thinkers and researchers regard it as an elegant solution to many scientific conundrums, while others challenge its credibility and relevance. Given our limited awareness of what lies beyond what we can observe, the idea of a multiverse contains the same theoretical intrigue as Schrödinger's cat paradox or the mysterious characteristics of dark matter. Even though it's an intriguing idea that promotes philosophical and scientific inquiry, it requires much more observational evidence before being widely accepted by the scientific community. Is the occurrence known as dark flow legitimate? This intriguing query is complicated. The concept of dark flow was used for the first time in 2008 to describe the peculiar motion of particular galaxy clusters that look like they are moving at velocities higher than what the current comprehension of the distribution of mass and the laws of nature would dictate. Dark flow argues that an invisible force, possibly connected to dark matter or dark energy, is drawing these galaxy groups in a specific direction. However, this concept is still controversial, as researchers have not reached a consensus on its authenticity. Some investigations support the possibility of dark flow caused by a massive underlying structure exerting gravitational pull. On the other hand, other studies have not found corroborating evidence and argue that the behavior observed could be due to data errors or sampling bias. Even though additional analyses provide some support for the dark flow theory, we still cannot declare with confidence that it really does exist, particularly outside the observable cosmos. Ongoing investigations and more specific data gatherings aren't necessary to decipher this mystery of the sky. What are your thoughts? Let us know in the comments. Make sure to subscribe and like us, and we'll see you in the next video. One of the most fundamental astrophysics mysteries is the actual composition of dark matter and dark energy. Together, they represent nearly 95% of the total dark portions of the universe's contents, with dark matter representing approximately 27% and dark energy about 68%. Despite their enormous impact on the shape and destiny of the universe, neither has been directly observed. Nonetheless, the future of space exploration appears to hold promise. Every new piece of information raises new concerns and deeper understandings. The universe, in all its magnitude and complexity, serves as a powerful reminder of the importance of scholarly investigation, whether shedding light on dark matter's mysteries, looking for evidence of alien intelligence, or examining the whole essence of human spacetime. Understanding the cosmos is an ongoing journey, and it will undoubtedly impact the course of our future for generations to come.